Recording on. Let's do a little bit of review from last week. Last week we were talking about finding the limits as x approaches infinity. And we talked about three different possibilities you can have. You could have because all we're doing is we're looking at the powers on top and bottom. So we could have a big power on top, small power on bottom. We could have a small power on top and a big power on bottom, or we could have the same. We could have the exact same powers. So if we have the same powers, so for example here we have a x to the second is the highest power on top, x to the second is power on bottom. So all we do is we take the coefficients in front, so that becomes -1 over, coefficient here is 1, so -1 over 1 is just -1. That's it. Now, if this one's the same way, the highest power on top and bottom are the same, so it's just going to be -1 over 4 or -1/4. That is if the exponents, if the powers are the same on top and bottom. Now, if they're not the same, for example, this problem here, I have an exponent. I'm going to change my marker here so I'm not erasing everything. I have to the second power here and to the third power here. So I have a small over big. So the bottom or the top is a very small number. The bottom is going to be a very huge number. So that is going to equal 0. Anytime you have a small over a big, and some kids would say, but Mr. Shanklin, they're really close. But when you get out to big numbers like 10,000, 100,000, this number, this power on the bottom is going to way overtake the top number. And that's why we say that it just becomes 0. I think we did this problem last week because I could rewrite this as 1 over 2 to the x to the x. So the top is a very small number. The bottom is a very big number. That's going to also be 0. In a problem like this, just take a look. I've got x to the third here. Got an x to the third here. Highest power on top and bottom are the same. So I just look at the coefficients in front, and I end up with 1/4. This one is a really interesting one. I think I had one very similar to this last week on the assessment. And when you think about it, this is the highest power on top here. So that's the square root of 9x squared, which really reduces to 3x, doesn't it? And the highest power on the bottom is 4x. So the powers are the same. So my answer would be just 3/4. Now I also had a problem very similar like this. I had something like the limit as x approaches infinity, and then I gave you a problem like 3x squared plus 4 over 5x squared minus 2 plus, and then maybe 5x to the fourth over 3x to the fourth. Not too many people got this problem right. So in this problem, we know that we can separate limits. So all I did is I just found the limit here. The powers are the same. So it was just 3/5 plus, and then the powers are the same on this term. That's 5/3. And then I would just have to add these two fractions together to get my answer. So there are a couple problems that did cause some problems on the last assessment, but hopefully that covers it. Any questions on anything from the first 4 weeks of school? Anything that you guys just don't understand that we can go over? You might have some questions after today. All right. Today, we are starting on Unit 2, which is derivatives. This whole chapter deals with finding the slope at a given point on a function and then writing an equation for that. Now, I hope you guys understand the equation, point slope form of an equation, because that's what we're going to use this year. So for example, if I gave you, let's say I gave you a point, and I said the point is 3, 4, and it has a slope of, let's say, -5. and I asked you to write an equation of this. Well, you know, it's not really set up to write in slope-intercept form. It's really set up to write in point-slope form. And point-slope form, again, is y minus y1 is equal to slope x minus x1. Okay, so here's my x1, y1. Here's my slope, so you just plug it in. So it's y minus 4 is equal to negative 5, x minus 3. There's my equation in point-slope form. Now, if the test asked you to write it in slope-intercept form, that's not a big deal. I mean, I would just multiply through here, so that give me negative 5x plus 15, and then I have y minus 4 is equal to that. I'd add 4 to both sides, and I'd end up with y is equal to negative 5x plus 19. So that would be slope-intercept form. This is point-slope form. I will tell you right now that I would rather have kids leave all of their answers in point-slope form. And if you are taking the AP test, never ever rewrite it into slope-intercept form. It just takes time, and it doesn't matter. They don't care. So we just leave everything in point-slope form. All right. So we're going to talk about the average and instantaneous rates of change at a point. The average rate of change is basically the slope between 2 points. So if this is 1 point down here, let me change colors so we can see this. If this is a point here, and this is a point, and we call this A f of A, and this is B f of B, and I wanted to find the slope of that, that is called the average rate of change. And we would just use the slope formula, f of A minus f of B over A minus B. And you could do it either way. You know, you go f of B minus f of A over B minus A. Makes no difference. But the average rate of change is just the slope between 2 points. That's it. That is all it is. Now, if they ask you for the instantaneous rate of change, that means if I had a point right here, I want to know what the exact slope of that is. That is called the instantaneous rate of change. So there's a huge difference, and that is what a derivative gives you. A derivative gives you the instantaneous rate of change at any given point. The average rate of change is just the slope between 2 points. The instantaneous rate of change is the slope at a given point. And now that is what we're going to be trying to do this week. So we're going to be trying to find the slope at a given point. So if I gave you this problem here, it says derivative at a point. This is a very, very important formula. Copy this down. F prime of A is equal to the limit as x approaches A of f of x minus f of A over x minus A. Okay? So what we're going to try to do is we're going to try to find the slope at a given point. And this formula right here is how you find the instantaneous rate of change at a given point. Okay? So now let's say I want my A value to be 2. Okay? So when x equals 2, I want to know what the slope, the instantaneous rate of change is of this graph. So at x equals 2, this is 2 here. I go up. Here's my thing. If I drew a line for slope, that's what it's going to look like. So I'm looking at that, and I'm thinking, okay, I don't know what the slope is just by looking at it, but I know it's positive, right? I know it's more than 1, because slope of 1 would look something like this, wouldn't it? I know it's probably more than 2, but let's check it out. So in this problem, my A value, I'm not going to use green, I can barely see that. My A value is going to be 2. So how do we use this formula? Well, f of x really means just plug x into your function. Well, my function is x squared. If I put x here, I just get x squared. So it's going to be the limit as x approaches 2 of f of x, well, that's just my function, x squared, minus f of a, but my a value is 2, so f of 2, well, what is f of 2? Well, if I put 2 in here, 2 squared is 4, over x minus a, well, again, my a value is 2, so x minus 2. All right. Oh, Look at that. It's exactly the same thing as we did in the first couple not chapters, but units. We have to find the limit as x approaches 2. Well, guess what? I'm going to factor this. X squared minus 4 is x minus 2, x plus 2, over x minus 2 as the limit as x approaches 2. These cross out. If I put 2 in here, 2 plus 2 is 4. This slope right here at x equals 2 is equal to 4. Now, if I wanted you to write an equation of this tangent line, and that's exactly what you have to do on a lot of the problems. So you have to write an equation of a tangent line at x equals 2. And tangent line is just the line that touches the graph in one point. And the slope is going to be 4. So what do I need in order to write an equation of a tangent line? I need point. And I need slope. Well, we just found the slope. The slope of this tangent line is going to be 4. What is the point? Well, we know the a value, or the x value, is 2. And if I put 2 in here, 2 squared is 4. So now I have a point and a slope. If I write my equation, I get y minus 4 is equal to 4x minus 2. There's the equation of this tangent line to the graph at x equals 2. That is a huge concept in calculus, is being able to write an equation of a tangent line at a given point. Now, a lot of times I don't give you guys time to work problems out. This is just the same problem. I am going to give you this problem, and I am going to turn off my mic, and I'm going to sit here, and I'm going to let you guys have time to work on this problem. So it wants us to find the slope, f prime, that is the f, when you see this, that means the derivative of f at 0. So basically they want us to find the slope at 0 of this function. So let me write the equation down again. The limit as x approaches a of f of x minus f of a all over x minus a. Okay, so there's my my formula. So what I'd like you guys to do is I'd like you to spend a little bit of time. Okay, I want you to use this formula, and I want you to solve this problem. What is the slope at 0? Okay, so I'm going to turn off my mic. I'm going to let you guys work, see how you do. All right. Did either of you guys get -3? I agree 100%. Very nice. Excellent work. Now, I don't know what this graph looks like. I'm assuming it probably looks something. Where's my marker? I'm assuming it probably looks something. I know it's a parabola. I mean, that's obvious. And at 0, it must be shifted over here someplace. So it must look something like this, because at 0, it has a slope of -3. Okay, so that's negative there. So how did we do this? Let's work through the steps. So I've got f of x. Well, that's just my function. So that's 2x squared minus 3x minus f of a. Well, if I put 0 into this function, 0, 0, that just gives me 0 here, all over x minus a. So that's x minus 0. Or just x, right? You don't even have to do that. So now I'm going to factor out an x on top and bottom, or on top. So that gives me 2x minus 3 over x. Those x's cross off. This is the limit as x approaches 0. If I put 0 in here for x, I'm left with negative 3. That is my slope. Now, if I asked you to write an equation of a tangent line at x equals 3, the first thing you should be doing is you should be putting down point slope, because that's what you need in order to write an equation of a tangent line. Well, we know the slope is negative 3. We know the point is 0, comma 0. Because if I put 0 in here, I get 0. So my equation, that equation, is going to be y minus 0 is equal to negative 3 x minus 0. If I wanted to write it in slope-intercept form, it would just be y is equal to negative 3x. That's my equation right there of the tangent line. Pretty amazing. Now, in a couple weeks, you will never use this again. You will look at that and you'll say, Mr. Shanklin, I know the slope, I know f prime of 0 is negative 3. I can see it. I know what it is. But right now, I've got to teach you the hard way before I show you the easy way. Okay? This is the hard way. But this formula gives you the slope at a point. Any questions yet? Because there's a couple problems on the assessment just like this. Any questions? You want to do another one, or are you okay? Make sense? Awesome. No questions? Amazing. Okay, now, wouldn't it be awesome if we could, like, for example, in this problem here, wouldn't it be awesome if I could come up with an equation of a function that would give me the slope at any given point? So what I'm saying is, if I could write an equation, we'll keep this function here. If I can write an equation that would give me, so for example, if I said f prime of 5, what is the slope at 5? Well, you'd have to go through all of this again, right? Well, wouldn't it be cool if we just had an equation that would give it to us? So if I said 4x minus 3, and I said, that's my equation that gives me the slope at any given point. Well, at 0, if I put 0 in here, it gives me negative 3. Huh? It works for 0. If I put 5 in here, it gives me 20 minus 3, so it would give me a slope of 17. Well, I could do it. I mean, I could see if f of 5 gives me 17, so I would do this all over again. I'd put 5 here instead. Okay? And then I would put x minus 5 in here down at the bottom. Now this would be a much harder problem to do. Can you see where I'm going to have my problems? I'm going to have to factor this thing, and then I would assume that it's going to factor out to x minus 5, x plus something. So it will factor, and it will give me 17. But if we could write an equation, and that is what this slide shows us. This is the next slide, and it says that we can find an equation of any function, and it will give us the slope at any given point. And that equation is the limit as h approaches 0 of f of x plus h minus f of x all over h. That is our function. Oh no, that seems a little hard. Okay, let's try an example. Let's go back to the original problem that we started with today. Y is equal to x squared. Okay, and we found that, and you can write this any way you want, y prime of 2, we found that the derivative at 2 is equal to 4, right? We found the slope of the function at x equals 2 was equal to 4. Now, in a couple weeks, you're going to be able to look at this and say, oh, I know what the, let me write this in function notation. You're going to look at this and you're going to say, oh, Mr. Shanklin, I know that the derivative of x squared is just 2x. I know that. Okay? You'll be able to look at it and tell me. But I'm not going to show you how to do that yet because we've got a lot of work to do. So this week, we're going to use this formula, the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay? So now we're going to do this problem. The hard part is f of x plus h. That means I have to put x plus h in where I see x. So this is going to be the limit as h approaches 0, and then x plus h squared minus f of x. Well, that's just x squared, right? That's just my function all over h. Okay, so all I did is I just plugged in wherever I saw x in my function, I put x plus h. So I just put it right there. Okay, now I have to work this out. And the hard part is the x plus h squared. That really is x plus h times x plus h. So if I did FOIL on this thing, I'd end up with x squared plus xh plus xh plus h squared, which is x squared plus 2xh plus h squared. Okay, do you guys agree with that? All I did was I just multiplied this thing out. So I ended up with x squared plus 2xh plus h squared, and I still have this minus x squared all over h. Right? So now it's like, okay, I'm going to simplify. Well, if I simplify this thing, the x squared and the minus x squared cross off. So I'm left with 2xh plus h squared. I'm going to factor an h out of the top. So that gives me 2x plus h over h, crosses out. This is the limit as h approaches 0. Well, if h approaches 0, this becomes 0. What is my derivative? 2x. That is the function that will give me the slope at any given point. Oh, it doesn't matter. I can ask you, what is the slope at 10? Well, the slope at 10 is 20. What is the slope at 40? Well, the slope of 40 is 80. This is called a derivative. A derivative gives you the slope at any given point on the function. And that is what we're going to spend the next 4 or 5 weeks doing, is we're going to be finding the derivative of all different functions. Because, you know, you've got the sine function, you've got cosine function, you've got e to the x, you've got log functions. We're going to find the derivative. We're going to learn how to find the derivative of all of these functions. And the reason we find derivatives is so we can find the slope at any given point, so we can write an equation of a tangent line. That is huge. Okay, so now I went through a problem, so now it's your turn. Now this is just notation for derivatives. If you start with f of x, you can write the derivative of f of x. The notation would be, I could write f prime of x, I could write dy dx. It all means the same. It just means this is the derivative, this is the derivative. Sometimes they'll go df dx. These are the two major ones that you will see in most books, dy dx. If you were given y is equal to 2x squared plus 4, usually then you would say dy dx. The derivative of y with respect to x is equal to, and then you'd find the derivative here. If you're given f of x is equal to 2x squared plus 4, and you wanted to take the derivative, then normally you would just write f prime of x, which just means the derivative of this is 4x. I should have just put 4x here also. So that's just notation that you need to know. All right, so now let's try an example. It says, for each function given below, find the equation of the tangent line at the indicated point. Okay, I'm going to make this a little bit easier. I'm not going to do this problem just of yet. Okay, I do want to do it because I believe it's a problem off our assessment tonight. or this week. And for those of you that show up or watch you'll have a problem done for you. I'm going to try a much easier one to start with. I'm going to ask you, so f of x is equal to, let's go x squared plus 4. And I want you to write an equation of a tangent line when x equals 2. Okay? So what you're going to have to do is you're going to have to use, the first thing you should do is you should always go point, because what two pieces, I always tell kids, when you're asked the question, what do you need in order to solve that question? So they're asking me to write a tangent line. Well, I know to write an equation of a tangent line, I need a point on the line and I need the slope. Well, the point is always pretty easy to find. I know the x value is 2. What's the y value of the tangent line? Okay. It would be 8. I just plug 2 in here. 2 squared is 4. 4 plus 4 is 8. So now I have my point. The only thing I don't have is I don't have the slope. And that's where we have to use this function. The limit as h approaches 0 is equal to f of x plus h minus f of x all over h. Okay, so now I'm going to let you guys work and see if you can give me the equation of the tangent line. Once you have it, just put it in the text box and we'll go from there. All right. Did either of you guys get an answer for this, or are you struggling with it yet? Slope, I got 2x. Now, 2x is not a slope. That would be your derivative. So if you came up with 2x as your derivative, then that is, a derivative is a function that you use to find the slope at any given point. So now if you wanted the slope at 2, you just plug 2 into the 2x and you end up with 4. That 4 would be your slope, not 2x. 2x is a function that gives you the slope at any given point on that graph. Okay? Now, let me say that I was looking at this problem and I'm thinking, one second, I have to sneeze here. Oh. Yeah. Okay. I was looking at this and it's like, I don't think I would have used this. Can somebody tell me why I wouldn't have used this? Why? I could have solved this problem without using this. And the reason is, we have another formula that's a whole lot easier. The limit as x approaches a of f of x minus f of a all over x minus a. That gives us, so this gives us the derivative. So this function gives us the derivative. And the derivative is a function that gives us a slope at any given point. Man, the wind just picked up. Holy moly. Holy cow. It's crazy windy right now. Okay, so you figured out that the derivative was 2x. That gives me, if I wanted to know what the slope is at 2, I just plug 2 in here. I end up with the slope is 4. Now, if I only wanted to know what the slope is at a given point, which in this problem, that's all I needed. So I could have just did f of x, which is x squared plus 4 minus f of 2. If I put 2 in here, that's going to be 8, right? All over x minus a. Well, 4 minus 8, so that's x squared minus 4. Oh, I'm sorry, I should have put 2 here because that's my a value. X minus 2, so that gives me x minus 2, x plus 2. Cross it out, put the 2 in there. I end up with 4 for my slope also. So I could have used this in this problem, and I didn't have to use this because it didn't ask me to find the equation of the derivative. Okay, so I could have used that. Either one would have given me the slope of 4. Then if I write my equation, I have y minus 8 is equal to 4 x minus 2. Done. Awesome. All right. Any questions on that? I love this stuff. But as I said, next week, you're gonna be able to look at this and you're gonna be able to tell me what, well, maybe not next week. I don't know if we do the power rule next week, but you're gonna be able to tell me what the derivative is just by looking at it. It's not that difficult. All right. Okay, I guess we have to go through this also. Connecting differentiable and continuity. So if you have a graph that has a corner, you cannot take the derivative at the corner. And the reason you can't is because what would the slope be right here? Because really, the derivative gives you the slope at any given point. Well, what's the slope here? Is it going to be negative? Is it going to be -1? Is it going to be +1? We don't know. So you can't take a derivative at a corner. So if you ever have a corner, can't take a derivative there. If you have, this is called a cusp, you can't take a derivative right here. Now, could you take the derivative over here and find the slope? Sure, I could find the slope over here. I could find the slope here. I just cannot find the slope at that cusp. So that's two different places I can't find it. If you have a vertical tangent, can't find the slope here. So that means it's not differentiable there. It's differentiable everywhere else, just not at that point. And if there's a jump, you can't take a derivative at a jump. All right, so now I want to go back and I want you guys to find the derivative of f of x equals x squared plus x, and I just want you to find the derivative of this. What does the derivative give us? It gives us an equation that gives us a slope at any given point. So I want you to find the derivative. So I want you to find f prime of x. And remember, you're going to use this formula. The limit as h approaches 0 of f of x plus h minus f of x all over h. This is a little bit tougher of a problem, okay? I'm going to tell you that right now. A little bit tougher, but I think you guys can do it. So I want you to find the derivative for me. And that is a function that gives us the derivative at any given point. Okay, so you guys try that, see what you get. I'm going to stop talking and let you work. Okay, but remember, it's the limit as h approaches 0. So that h should really be a 0, right? So your answer should just be 2x plus 1, right? Because remember, you've got, it is the limit as h approaches 0. Well, if you have an h in your answer, you got to put a 0 in there. So your answer should be 2x plus 1, which I agree with 100% that that is the answer. And in a couple of weeks, you're not going to use this anymore. You're just going to look at that and say, oh, Ms. Shanklin, the derivative of that is 2x plus 1. Boom, done. That is as fast as you're going to be able to do it. I guarantee you, when you learn the tricks of calculus, you will never use this again because they are so easy. Okay, so let's do this the long way. And that is, one second here. I've got to get my clicker out because somebody's coming down our driveway and my dog is out and he will go nuts. Oli, get over here. Come. Hey, come. Come on. In the house. Hey, 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 in the house. All right, sorry about that. All right, so let me work this problem out for you. If I was going to do this, I'm going to put x squared plus x. Well, I'm sorry. I'm not going to put x squared plus x. I'm going to put x plus h wherever I see x. So that's going to be the limit as h approaches 0 of, and then that's going to be x plus h squared plus, and then I have another x here, so I have to put x plus h again. So that is the first thing, minus f of x. Well, that's x squared. Now remember, I put parentheses in here because it's going to be really tricky. All right, so that's my top, and the bottom is just h. Okay, now this is where the fun begins. I have to square, x. So this is going to be, so I have x plus h times x plus h. So that's going to be x squared plus xh plus xh plus h squared. So that's going to give me x squared plus 2xh plus h squared plus x plus h minus x squared minus x. Because remember, that minus sign goes to everything, okay? All over h. I'm going to cross off the x squared here and the negative x squared here. I have an x here, I have a negative x here. So what am I left with on top? I'm left with 2xh plus h squared over h. I'm going to factor out an h. So that leaves me with h x plus h over h crosses out as, did I mess something up here? Because my answer doesn't look like it's going to be right here. It's going to be an h. I'm going to bring that out. Oh, I left a 2 out of there. that needs to stay. So I've got 2x plus h. So that crosses out. Still missing something here. All right, what did I mess up? X squared. Oh, I didn't put the x plus h in there. Yeah, okay. All right, so I had this. I'm going to write it over here. So I had x squared plus 2xh plus h squared, but I still had that x plus h here, plus x plus h minus x squared plus x. Okay, I think I did it right now. Maybe not. So my x squareds cross off my x squareds. My x crosses off my x. There's my last h. Okay. All right, so I have 2xh plus h squared plus h over h. And then I'm going to factor out an h. And if I factor out an h, I'm left with 2x plus h plus 1. Those h's cross off. Now if I put 0 in there, that goes away. I'm left with 2x plus 1. That is my derivative. That is a function. A derivative is a function that will give me the slope at any given point. So if I wanted to know what the slope of this graph of this function is at x equals 1, I just put 1 in here. 2 times 1 is 2 plus 1. That would be, the slope would be equal 3. All right. Any questions on that? It's a lot of work. There's no question. Now, if you have, I still remember when I was in college, they would give us problems like this. They would give us x to the 4th plus 5x squared plus 3. You put x plus h into here, so now you have to do x plus h to the 4th plus 5 times x plus h to this. I would never do that to you guys. Never. But I think my professor was trying to make a point that this could be really time consuming. So when you learn the tricks to it, you don't have to do that anymore. All right. I'm going to give you 2 problems off the assessment for tonight. Okay? Because I said I always want to give you guys an advantage because you come to the live sessions. This is a problem. F of x is equal to negative 2x plus 5. And the second problem I want to go through, f of x is equal to 4x squared plus 1. And both of these, it says to use, let me read the directions for you. Let me go back to the test. The directions say, use the definition of the derivative to find the derivative of each function with respect to x. So what are they asking us to do? They're asking us to find the derivative, and the derivative is the function that gives us the slope at any given point. So you're going to use the limit as h approaches 0 of f of x plus h minus f of x over h. And you're going to do it on both of these problems. So I'm going to give you guys a little bit of time to work on these 2 problems, and then that is it for today. So give it your best shot, and then we will walk through both of the answers. All right. First one, -2. Second one, 2x. I disagree with the second one. First one, I agree with. Second one, since I know how to take a derivative, I know it's going to be 8x. So, must have made a mistake someplace. Let's take a look at it. And that's why it's nice when you understand the rules to it, because it's so, you can just look at it and it's like, oh, no, not 2x, it's going to be 8x. All right, so in this first problem, I'm going to put x plus h in for x. So I end up with 2x plus h. Now, obviously, I should be writing the limit as h approaches 0, right? But I always put it in at the end. I really should be putting it in all the time, but I'm kind of lazy sometimes. Plus 5 minus, and then my whole function again. Well, that's -2x plus 5 all over h. And a lot of times I won't even put this all over h until I simplify everything down, because I know I have to divide by h at the end, but I know I have to simplify that top first. Okay, so if I simplify the top, I end up with -2x plus -2h plus 5 plus 2x minus 5. Okay, remember that minus sign goes to both these terms. So let's see here. The 5 crosses out the 5. The -2x crosses out the 2x. I'm left with -2h here, which for me, I end up with -2h over h. The h's cross off, so I'm left with just -2. The derivative, f prime of x equals -2. So, can you tell me what the slope is at 10 when x equals 10? -2. What is the slope when x equals 20? How about 30? And couldn't we tell that before we even did the problem? When you think about it, here's my equation, -2x plus 5. What is that graph? -2x plus 5, that's my graph. The slope is -2 no matter where you look at it. So doesn't that make sense that the slope or the derivative or the slope at any given point should be -2? I mean, that it just makes sense. So if you ever have a linear function, you really don't have to do a whole lot of work. You can just look at the slope and say, oh, that's got to be my equation for the slope. It's just going to be -2 all the time. All right, now the second problem. All right, so again, I'm going to take the x plus h and plug it in for x squared. So I've got 4x plus h, quantity squared plus 1, minus, and then again, I have to, my 4x squared plus 1, all over h. Again, I probably wouldn't do the minus h or over h until I got to the bottom, but I'll put it in there. Now, you'll notice if you do enough of these problems that you end up with x plus h squared a lot of times. So this is just going to be 4 times x squared plus 2xh plus h squared plus 1 minus 4x squared minus 1. I'm going to multiply through by the 4, so I end up with 4x squared plus 8xh plus 4h squared plus 1 minus 4x squared minus 1. Whew. All right. Now I start crossing things off. I've got the 4x squared, negative 4x squared, gone. I got a plus 1, minus 1, gone. All right, so I'm left with, on top, 8xh plus 4h squared. I'm going to factor out an h. So I've got 8x plus 4h as the limit as h approaches 0. Well, if h approaches 0, that is going to make that 0. Well, 4 times 0 is 0. I'm left with 8x. And I knew it was going to be 8x because I can do these in my head. Ah, there you go. Yep. And it's tedious work. There's no question about it. No question about it's tedious work. But I just did 2 of the problems, or you guys did them also, off the assessment for tonight. So, and this is the first 2 assessments, 5A and 5B, just multiple choice. The last one, 4C, is the one where you have to find the derivatives and all that. Okay? Any questions? That I talked a lot today, but we did go through a lot. And you guys are going to be amazed when we learn how to do these just by looking at them. There won't be any work at all. You'll be able to look at 4x squared plus 1 and say, oh, my answer is 8x. You'll be able to look at 5x to the third plus 4x plus 5. Could you imagine doing that using this? Well, I can tell you right now it's 15x squared plus 4. Done. And it's not because I'm smart. Trust me. You guys are going to be able to do the same thing as fast or faster than your old teacher. All right, that is it for this week. If you have any questions, please never hesitate to email or give me a call. You guys have a great week. Get outside and enjoy the weather. Okay, I got some questions wrong. May you please explain it? I absolutely can. I'm just going to erase this here. Okay, I've got to go in and take a look because I don't remember what you did wrong. So let me just go into the Unit 1 test here. Got to go into my grade book. All right, Unit 1 test. Where is that? Final assessment. Couldn't have got too many wrong. You got a profession on it, unless I'm looking at the wrong thing. Here is your feedback. Part B, sine of 4x over 4x is equal to 1, so you need to rewrite. Oh, that is a limit, right? The limit, so number 1, I got to go to number 1 here, see what the problem is. It's probably the limit as x approaches 0, right? Yeah, okay. So that is an awesome problem. And in the beginning of the semester, I told you that you have to know what this graph looks like. I said the sine of x over x looks like this. It's kind of, it gets bigger and bigger and bigger until it gets up to 1, and then it does this, all that, okay? Do you remember that? Okay. Well, the sine of 2x over 2x, exactly the same graph. Sine of 3x over 3x, the same graph. So the limit as x approaches 0 of all of these graphs is going to be 1. Okay? So now that function, now I don't know what the equation is anymore. The sine of 4x over, okay, the sine of 4x. So you have the limit as x approaches 0 of the sine of 4x over, let's see here, 2x squared minus 10x. 2x squared minus 10x. Minus 10x. Okay? So what I really want is I want 4x on the bottom. Okay? So I'm just going to factor the bottom. I'm going to pull an x out of there. So that gives me 2x minus 10 over a sine of 4x. Okay? I need 4x on the bottom, because if I can get a 4x on the bottom and sine of 4x, so I'm going to multiply top and bottom by 4. So I end up with 4 sine of 4x over 4x 2x minus 10. I'm going to just take what I want. I'm going to leave this times and then sine of 4x over 4x. See, I just kind of split it up. I mean, this is multiplication, right? So I can just write it. I just wanted to write this together. Why did I want to write that together? Because it equals 1. This whole thing is 1. So what am I left with? I'm left with 4 over 2x minus 10. And this was the limit as x approaches 0, right? So I just put 0 in here now. So I'm left with negative 4/10. Pretty amazing problem. Love it. That is a trying to maneuver things around. That's a great problem. All right. Number 2, part A. Number 2, part A. All you need to do was find the limit. Oh, we talked about this in the beginning of class today. I said that there was a problem, and that was the problem. Let me get rid of this. So it was, so that was a limit problem, but it was 4x squared plus 4. So I had, every time I move away, I have to, so 4x squared, was it minus 4? Plus 4, and 9x squared minus 3, 9x squared minus 3, plus, and then I had 7x to the third minus 4x, 7x to the third, 4x over 6x to the third. Okay, now this one was super easy. Not a whole lot to do, because all you have to do, because I could rewrite this as the limit as x approaches infinity of this problem here, plus the limit as x approaches infinity of this problem here. Well, this one, the limit as x approaches infinity, I've got 4x squared, 9x squared, x squared is my highest, so that's 4/9, plus, and then here, 7x to the third, 6x to the third, 3 is the highest power on both, so that's 7/6. If I just add that together, boom, I am done. Okay, so you can break limits apart. If there are two separate problems, you just find the limit of both of them separately. Number 3, 2b function is not defined at 4. Let's see here. Number 3, 2b. Oh, because if you look at this function, 2x plus 8, when x is greater than 4, and then I don't know what it was when it was less than 4, x squared, oh, I had it, x squared, I have it incorrect, x squared when x is greater than 4, and this is less than 4. Okay, so this function is not defined at 4. Why isn't it defined at 4? Well, I'm supposed to graph this when x is less than 4. So 2x plus 8, that's going to look something, so less than 4. So it's going to look something like this. And then it's an open dot because it's less than 4. And then x squared when it's greater than 4. So at 4, it's not defined at all. It was a tricky problem. Now, if they would have had an equal sign here, less than or equal to 4, your answer would have been fine. It would be continuous. But it's not defined at 4 because there was no equal sign there on either one of them. So it was defined for everything less than 4. It was defined for everything greater than 4. It was not defined at 4. So that means it has to have a hole there. Okay. Does that help on that? Any other questions? Got to see if there's anybody in my BC calculus class right now because they start at 3 o'clock. All right. You have a great day. Get outside and enjoy the weather. Bye.